Hello all, this is Mr. G, and this is our warm-up for today's lesson. So pause the video right here, give this problem a shot, and come back when you think you have an answer. We're going over it in 3, 2, 1, let's hit it. It says, based on each statement, how many solutions could the following system have? So what we have here is an incomplete system. An incomplete system. We've got y equals 2x minus 1 and y equals mx plus b. We have two variables here where we would need numbers if this was going to be a solvable solution, even just to figure out how many solutions there could be. So let's take a look at the first situation. So they say m equals 5. Well, if m equals 5, that would mean that, okay, this first one would have a slope of 2, and the second one would have an m value, a slope of 5. If the slopes are different, then that automatically means there would be one solution. One solution, which means it would be an independent system. An independent system has one solution. So, okay, if the slopes are different, one solution, we're done. Now we move on to number 2. The second situation, okay, so what if this m value was 2? What if this slope was 2? Well, then the two slopes would be the same. They would both of these lines, would have a slope of 2. Now, let's think about this. If they have the same slope, they could be parallel, but they don't have to be parallel. They could also be right on top of each other. They could be coinciding lines. So here in number 2, there's actually two possibilities. If they're parallel and if they have the same slope and are parallel, that means there would be no solution. So no solution. But if they have the same slope and the same y-intercept, because remember, we don't know what this y-intercept is. It's a variable. It's a b. If they have the same slope and the same y-intercept, then it would be infinitely many. They'd be coinciding lines. So it's no solution or infinitely many solutions. So there were two possibilities for that second answer. Hopefully this was the answer you got on your own. If not, don't worry about it. Everyone makes mistakes. We'll just go over it and that'll be cool. All right, let's take a look at our objective. Today's the 14th. We're doing chapter 3, section 2. And after today, we should be able to solve two variable systems algebraically. Solve two variable systems algebraically. So yesterday, it was a lot of, okay, let's classify these things. Let's put these things into groups like, okay, so we've got one solution, we got no solutions, and infinitely many solutions. Today, we're actually going to be solving these systems, which hopefully, fingers crossed, is a review from Algebra 1. Hopefully you should remember that there are two ways to solve, well, two primary ways to solve a system algebraically. The first is elimination, and the second is substitution. Now, I don't really care which substitution. I don't care which method you use. Some students are better at one, some students are better at the other. It doesn't make a difference. I prefer substitution most of the time, but it's, how do I want to say this? What this is really about is being to identify, okay, what method would be best, or better, I should say, for a given system. So for elimination, we want the x's and y's to be lined up. So if we're looking at something like, I don't know, 2x plus 5y equals 17, I'm just making this up, and, I don't know, 8x minus 10y equals 20. Again, I'm just making this up, I have no idea. This would be a great candidate for elimination because the x's and y's and the constants are all lined up. Okay, we've got the x's right there vertically, got the y's right here vertically, and the constants right there vertically. It doesn't have to be x, then y, then the constant, but just lined up vertically. So if we're going to use elimination, we need to make sure that one of our variables, the x's or the y's, gets eliminated, cancels out. And the only way we can do that when we combine our two equations, the only way they're going to combine and eliminate a variable is if we have opposite coefficients. So important, I'm going to write that down. Opposite coefficients. So hopefully remember that coefficient means the number in front of the variable. And opposite means same number, different sign. So for example, here, I don't see opposite coefficients. I would probably match up the y's here. So we've got a positive 5 and a negative 10. To match them up, all we would have to do is multiply here by a positive 2. And that would turn this positive 5 into a positive 10, and then we're ready to eliminate. Hopefully this is sounding sort of familiar from Algebra 1. So that's elimination. Now substitution, is a little bit different. Whenever we're looking for substitution, we don't want opposite coefficients. We want either y equals or x equals. We want one variable in one of our equations, doesn't matter which one, to be by itself. So substitution is a good method to use when you're looking at an equation and it's like, oh, that variable x or y is almost isolated. So I can just get it by itself and then use the substitution technique or strategy, whatever. So what we're going to do next, we're going to practice the elimination strategy, then the substitution method, and then we're going to go through a few of these problems and sort of see how beefy our skills are, see how good we are at this. So first, let's do some elimination review. Example 1 says 2x plus 6y equals 326, and 7x minus 8y equals negative 338. I've got a feeling that I'm going to need a calculator to make sure my numbers are correct here, so I'm going to grab that now. Now, this one just screams elimination. We've got the x's, the y's, and the constants all lined up vertically, just waiting for us to add them together, waiting for us to combine them. But before we can combine them, we have to make sure, okay, is something actually going to eliminate? Is something going to cancel out? Because if I just add these two together right now, nothing's going to cancel out. We're going to end up with a 9x and a negative 2y. That doesn't help us. We need to have only one variable by the time our elimination step is finished. So let's see. We could match up the x's, like multiply this by, tell you what, let me color code this. Let me do the top one in green. So like we could multiply this top one by a negative 7 to make it negative 14, and then multiply down here by a positive 2, and that would give a positive 14x. But I'll be honest with you, ladies and gentlemen, I don't think that's the easiest way to do this, because then we're going to have to multiply 326 by a negative 7. That's going to be a number I'd rather not deal with. So instead of doing it that way, which still would have given us the correct answer, but I think a faster way is going to be, let's try and match up these y values. So we've got a 6y and an 8y. So essentially our goal, what we're trying to get to, is a 24y. We want one of these to be a 24y and one to be a negative 24y. So to do that, we can just multiply the top, the green, by a 4. That'll give us a positive 24. And then multiply the blue by a positive 3, and that'll make it a negative 24y. All right, so now let's just distribute. So 4 times 2x becomes 8x, plus 4 times 6y is 24y, and then 4 times 326 is 1200, 1280, 1304, 326 times 4, 1304, okay, 1304. Now we're going to do the same thing with the blue. We have to distribute that 3 to every term we see. So 3 times 7x becomes 21x. 3 times negative 8y is negative 24y, which is good because now we have our opposite coefficients. And then 3 times negative 338 is negative 900 and 270. That's 1170, 1194. Did I do that correctly in my head? 338 times 3? 1014. Oh, what did I do wrong? Oh, well, let's just move on. So we get 1014, or negative 1014, I should say. And now we're ready to combine. Now we can just add everything together and see what we get. So 8x and 21x becomes 29x. 24y and negative 24y and negative 24y cancel each other out. So we could put a 0y there, like a plus 0y, but I don't think we need to do that. I'm just going to leave it blank. And equals, on this side, we get 290, 1304 minus 1014. Yep, 290. Now it's a one-step equation. We divide by 29 and we get 10. 290 divided by 29, x equals 10. All right. Now, whether you're doing the elimination or the substitution method, once you find one variable, whatever variable you find first, x or y, the next steps are always the same. You just take that variable, in this case, x equals 10, or the value for that variable, 10, and we're going to plug it back in. We're going to substitute it in to one of our equations. I think the original green one is going to be the easiest way, or the easiest one to use. So I'm just going to copy that down here. So it's 2x plus 6y, 326. Let me get a little bit more space. So it's 2x plus 6y equals, what was it? 326. And now we're just going to substitute in, substitute in a value of 10 wherever we see an x. So 2 times 10 plus 6y equals 326. And now we only have one variable in this equation, so we can solve it for y. If you can skip some of these steps, that's a good thing, ladies and gentlemen. I'm just going to show all my work. 2 times 10 is 6. Excuse me. 2 times 10 is 20. That's what I get for trying to think and talk at the same time. Equals 326. And two-step equation, take away 20 from both sides. We get 6y equals 306. Divide everything by 6 to get y by itself. And we get y equals 51, if I'm not mistaken. Let's double check that. 306 divided by 6. Yep, 51. So y equals 51. So let's put our answer together a little bit more organized. So x equals 10. Let's put them both together. X equals 10 and y was 51. Yeah, y equals 51. That's our final answer. Now, if you wanted to write this as a coordinate, as an ordered pair, you could do that since it's x and y. It would just be 10 and 51. You don't have to do that, but it's an option. It's an option. So that was a quick review of the elimination method. Hopefully this looks familiar from Algebra 1, because moving forward, I'm going to sort of assume that we're good at this method. Now, if you're thinking right now, oh no, I don't know if I am good at this, I might need some more practice, that's okay. We're going to talk about what you can do if you need more practice later. But now let's jump into the substitution method with some substitution review. Now remember, with substitution, we don't care if the x's and y's and the constants are lined up vertically. It's all about looking for one variable all by itself. So either x equals something or y equals something. So, and right away, this really looks like a good candidate. This system looks like a good candidate for the substitution method because of this second equation. This is going to be very simple to get either x or y by itself. I would probably want to get y by itself, because if we get x by itself and divide by 12, we're going to end up with a fraction, and we'd rather not deal with that. So let's divide everything by -6, and that will turn this into a -2x equals y when the -6's cancel out. Now, the key for the substitution method is that y equals -2x. That means any place we see a y, we can substitute in, we can plug in a -2x, and the equation stays true. It stays the same. So basically, I'm going to rewrite this equation, but wherever I see a y, I'm going to plug in a -2x. So it becomes 4x minus 9. I see a y, so I put times -2x equals -1760. Now, some students ask a good question at this point. They say, oh, okay, wait a minute. So does that mean we always have to solve the second one and then plug back into the first one? No. If you wanted to get the first equation, either x by itself or y by itself, and then plug into the second equation, that would work too. It's just much easier in this case to solve the second equation and then plug back into the first. So you don't always have to go second into the first. Either direction is fine. All right, now this is an important question. Students who understand what's going on will be able to answer this question. And it's okay if you don't have an answer right away, but I want you to start noticing this. Why is this step any better than what we started with? Because to a lot of students, if they're not paying attention to what's important, this might look worse. I mean, look, we've got like more negatives, we got parentheses. How is this any better than what we started with? Those equations at the start, they looked easier to deal with. So why is this equation right here better? It's because there's only one variable. Well, I guess there's two, but really, they're both x. So we say that's just one variable. Since we see only one variable, we're able to solve. And that's exactly what we're going to do. So we get 4x, -9 times -2x is plus 18x equals -1760. And then, well, we combine our like terms and get 22x equals -1760 divided by 22. That can be 80. -80, I should say. 1760 divided by 22. Yep, -80. So x equals -80. And now, again, just like the elimination method, or rather, whatever method you use, elimination or substitution, once you find one value, you just plug it in. The rest of the problem is exactly the same as the elimination method. I think this equation is definitely going to be easiest to deal with. Actually, I've got an even easier one. Let's use this one. You know, it's not one of our original equations, but as long as we did our work right, that equation should still work. So let's plug it in. So it's -2x equals y. Let me rewrite it down here. -2x equals y. And then we can just plug in x. It becomes -2 times -80 equals y, and that becomes a positive 160. So let's write our answer. So x equals -80, y equals 160. And if you want to write it as an ordered pair, that would be -80 and 160. You don't need to do that, but it's an option. It's an option. All right, so we just reviewed the elimination method and the substitution method. What I want to do now is do 2 more problems together. We're going to do example 3, example 4, then I'm going to give you your homework. Now for each of these, I don't really care which method you choose to use. Like if I'm using one method and you'd rather use the other, go for it. We'll get the same answer, as long as we both do our work correct, I should say. But I'm going to sort of go through these and walk you through my thought process and try and point out some things that trip students up. But basically, example 3 and example 4 are going to be more the type of systems I would expect from an Algebra 2. I mean, I'll be honest, ladies and gentlemen, example 2 and example 1, that's Algebra 1. That's Algebra 1. Now, if you need some more practice with it, that's okay, and we'll talk about that later in the video. But right now, let's take a look at example 3. So it's negative 3.5x plus 6.3y equals negative 0.9, and 12.6y plus 1.8 equals 7x. So I'm just trying to think substitution or elimination. I'm thinking elimination here. I mean, if we wanted to get this x by itself, we could divide by 7, but I really don't feel like dividing a 1.8 and a 12.6 by 7. I don't feel like dealing with that. So let's just go for elimination. So let's try and get everything lined up. I think it's going to be easier to color code this. Let's make this one blue and this one green. I forget if that's the order I did earlier, but whatever. I don't think anything needs to change with the blue at all. So I'm going to leave the blue leave the blue alone, rather. With the green, we've got to sort of get everything together in the right order. So I'm going to show my work here, but hopefully you're able to do some of this in your head. So essentially, we need to subtract 7x from both sides, so we can put that in front to match up with the x in the blue. And then we need to move, let me slide this over a little bit. Then we need to move the constant, the 1.8, to the other side. So it'll match up with the negative 0.9 from the blue equation. So this green becomes negative 7x, and then we want the y, so it's plus 12.6y equals negative 1.8, because this canceled out and that canceled out. Is that correct? Yep, it looks good. Now we can just take our blue and rewrite it down here, the blue equation, I should say. So it's negative 3.5x plus 6.3y equals negative 0.9. Okay. Now we have to ask ourselves, it's time for the elimination step, or rather, are we ready for the elimination step? That's a better way to phrase it. If I look at the green and the blue, we are not yet ready to eliminate because nothing will cancel out. We don't see those opposite coefficients. So that means we need to multiply one or both of these equations by something. And this is really the key step if you're going to use elimination. You have to know what type of, you have to know what number you're trying to get to and how you're going to get there. So I think it's going to be easiest to match up the x's. And the reason I chose the x's is as soon as I see that 7, or the negative 7 and the negative 3.5, I see, oh, if I double 3.5, I'll get that to 7. And remember, that's what we want in elimination. Same number, but different signs. So if I multiply this whole equation by 2, that'll turn the negative 3.5x into a negative 7x. That's where that 2 came from. But it's actually, we want it to be more than a 2, because see how both of these signs are negative? We want one to be positive. So I'll just multiply by a negative 2, and that'll fix that problem. So let me scroll down a little bit more. So the green equation stays the same. It's still negative 7x plus 12.6y equals negative 1.8. But the blue equation now changes when we distribute that negative 2 in. So negative 2 times negative 3.5 is a positive 7x. Negative 2 times positive 6.3y is negative 12.6y. Equals negative 0.9 times negative 2, that's a positive 1.8. Okay. Now we're ready to eliminate. And as we eliminate, look here for a second. What's going to happen? Okay, the x's are going to cancel out. Negative 7 and positive 7, they go away. But the y's cancel out as well. We've got a positive 12.6y and a negative 12.6y. So on this side, we end up with a 0, which should make us pause for a second because something weird happened here. We didn't just get a, how do I want to say this? Getting a 0 on this side of the equation is more dramatic than getting a 0 anywhere else because that's where all our variables were. The x's were eliminated and the y's were eliminated. All the variables canceled out. Now, whenever this happens, when we use the elimination method, I don't think this will ever happen with substitution. I guess it can in substitution. I should have said this. Whenever we're solving a system, I'll put it this way. No matter what method you're using, if all your variables go away, or really solving any equations, if all the variables go away, well, for a system, you've got 2 options. It's either no solutions, no solution, or it's infinitely many. And it's only going to be one. Obviously, it can't be both. Infinitely many. Now, I really want to drive this point home. This only happens if all the variables disappear from the equation. Now, what tells us whether it's no solution or infinitely many solutions is the equation we're eventually going to get. Because remember, we didn't finish eliminating it. We still have the constants to add. If this equation comes out to something that's true, then it's infinitely many solutions. So by true, I mean, 2 equals 2. -7 equals -7. An equation that's true, two numbers that are equal. Now, if we end up with something that's not true, a false equation, which would be like 1 equals 15, or 9 equals -2, something that's not equal, then it would be no solution. So let's finish our elimination step and see what happens. -1.8 and 1.8 cancel out, we get 0. This is a true equation. So that means it's infinitely many solutions. So the answer is not 0 equals 0. The answer is there are infinitely many solutions. It's not no solutions this time. Remember, it would have been no solutions if we got 0 equals 1 or 0 equals really any other number besides 0, an equation that does not make sense. All right, so that's our answer, infinitely many solutions. There we go. Let's do one more together in this video. So solve the system. So we got x minus 7y equals -320. And 7 over 5y minus 2 over 5x equals 72. All right, now before I even deal with, elimination or substitution, I see something I want to get out of the way. So again, I'm going to color code these blue and green just so it's easier, or hopefully easy for everyone to follow which equation is going where. That green equation has me worried because we have division there. And I specifically chose those words, or I chose those words specifically and carefully. I didn't say we have fractions. We have division. Now, we do have fractions, but remember, this fraction bar, both of them, mean division. And the more you look at it that way, the easier it is for you to see how to get rid of it. Because even though we have fractions here, which I would call division, it's sort of an advantage because they're both, how do I want to say this? Both denominators are the same number. So essentially, we're dividing that entire side of the equation by 5. Now, I want to cancel that out. So let's think about this. Go all the way back to Algebra 1, maybe even 8th grade. If you've got division in an equation, how do you cancel it out? Well, inverse operations, you cancel it out with multiplication. So we're going to multiply this whole equation by something to cancel out a dividing by 5. What cancels out a dividing by 5? Multiplying by 5. Okay. Now I want to be real clear, ladies and gentlemen. This is even before I chose substitution or elimination. This has nothing to do with an elimination step, which I can understand some students thinking it was. So like, where was I? Oh no, this is substitution. Oh no, we did elimination here. Yeah, so I could see some students thinking, oh, so this is like when we multiplied -2. We're doing the exact same thing here, right? No, we are multiplying, but the intent, the motive matters. Here we're multiplying to cancel out division. In the other problem, we were multiplying to create opposite coefficients. We might need to do that at some point, but we'll see. So let me see. Let's distribute this. So 7 over 5 times 5 is just 7y. Minus 2 over 5 times 5 is just 2. Bring down the x. Equals, and then 72 times 5 is 360, if I'm doing that correctly. Let me double check myself. My brain is fried at this point. 72 times 5. Yeah, we got 360. Good. Okay. Now, before I do anything with the blue, let's think about this. We've got either substitution or elimination. I actually think either method would be perfectly fine here. You could do elimination or you could do substitution. I'm going to show you substitution just so I'm sort of giving you a mix. I don't want to do like just a bunch of elimination in this lesson. So if I were going to use substitution, I would definitely get this x, or the x in the blue equation by itself, because all we have to do there is add 7y. So when we add 7y, the blue equation becomes, x equals 7y minus 320. And then from here, we can just substitute in. So I rewrite the green equation with 7y minus 2 times, and then since I see an x, I substitute in what x equals. X equals 7y minus 320. Oh, color coding is going wrong. Come on. There we go. Equals 360. And now we can just go through and solve this. Now again, if you want to use elimination, that's cool. I'm just going to show all my work. Okay, the blue and green's messing with me. I'm just going to black so it's more uniform. So let's see. It's 7y minus, let's distribute. So that's going to be 14y plus 640 equals 360. And then, tell you what, as we combine like terms, let's move the constants together just to make this a little quicker. So 7y minus 14y is negative 7y equals, I'm too tired, 360 minus 640, I'm just using a calculator, 640. That comes out to negative 280. Divide both sides by negative 7, and that should be positive 40. I think I'm right, 280, well, it's definitely going to be positive. Yep, positive 40. So y is positive 40. And now we just take that and plug it back in to whichever equation looks easiest to deal with. I'm actually going to use this one. X equals 7y minus 320. Let's copy that one down here. So what was it? I already forget. 7y minus 320. So x equals 7y minus 320. Again, if you want to substitute in as you're writing that and go straight to x equals 7 times 40, that's cool. I'm just showing all my work, so hopefully the video is easier to follow. And that becomes x equals 280 minus 320, and that should be negative 40. I'm going to double check myself because I don't want to make a mistake. Yep, negative 40. So x equals negative 40. So let's put our answer over here. X equals negative 40, and y equals positive 40. And again, like we've been doing all class long, if you want to write it as an ordered pair, more power to you. Negative 40 and 40. All right. A lot of work just to get through. How many examples was that? 4 examples. So let's go to our homework at this point. Now your homework's going to be a little weird, okay? Of course, this is in the way. Let's move that. All right. So the homework is on the left side. So here I'm going to cover the right side, so you're only looking at the homework right now. I don't want anyone to be confused. The homework is I want you to try example 5 on your own. Hopefully you have some time to at least start that right now in class. And also I want you to do page 148, number 62. So you have 2 problems for homework tonight. Example 5, which is to solve the system right there, x plus y, blah, blah, blah. And do page 148, number 62. So if you don't have the book at home, make sure you take a picture of that problem before you leave class. Now, if you are a student who is thinking, oh man, when Mr. G was talking about how I should remember this stuff from Algebra 1, like that was 2 years ago, and like last year was a remote year, I don't remember this as much as I wish I did. That's totally okay. There's nothing wrong with that. It's just a sign that you might need to do a little bit more work on your own. And sometimes students think that's like a badge of shame or like a scarlet letter. It's like, oh, I had to do extra work on something. There's nothing wrong with that. That's part of being a good, responsible student. There were plenty of times in my career when I was a student, when I was sitting in class, go, wow, everyone else seems to be getting this. I'm not getting this. I need to do some extra work. I got to show up to office hours if it was in college, or stay after school and get some help or something like that, okay? But if you want some extra practice problems, you can work on page 147, 44 through 52. I want to be really clear here. That is not your homework. All right? The homework is the 2 problems on the other side of the board. But if you're thinking, man, I need some extra practice, I really want to make sure my skills are on point, then you can practice numbers 44 through 52 and check the answers to the odds in the back of the book. All right, that's our lesson for today. Hopefully this made sense. As always, if you have questions, don't be afraid to reach out to me. But otherwise, enjoy the rest of your day.